In this tutorial, we're going to focus on refining the ventilation tube area. So we're going to do an extrusion around this entire area we're selecting right now. We're going to round out the little piece behind it a bit more. And then to finish out this tutorial, we're going to be using curves and some arrays to create a nice hexagonal pattern that is present on the ventilation tubes. On the note of rounding out the section behind this ventilation area, I'm going to show you how we can use Booleans to achieve this, as trying to manipulate just all the vertices and edges is a little bit harder. So I'll show you how to do that, as at the moment you'll notice that we don't really have a nice rounded sort of shape there, but we purely have what we have at the moment because we only had a very limited space to work with. In saying that, I'll leave you guys to watch the next couple of minutes as we space out some of our topology and start to make that inward extrusion for the ventilation shaft a little bit deeper so that we can fit in a curve later on. Once we get to the Boolean section of rounding out the space behind the ventilation tube, I will chime back in just to explain the methodology and exactly what it is I'm doing and how it's going to all work out. Okay, so we're about to do the Boolean operation to round out this area, thus why we've just adjusted where the 3D cursor is. I make a bit of a mistake. Once we bring in this circle, I take the vertice count down from 32 back to 24. I thought having a lower poly count on the circle would make it easier to work with. I find out afterwards that it's actually easier to work with 32. So don't bother going ahead and changing the vert count there. As you'll notice in a second, I go ahead and once I've got the positioning and scale of the circle to a place that I like, I actually go ahead and bring in a new circle and bump up the count to 32 to then do the Boolean operation. To try and best explain the scale and positioning of the circle that I'm using right now, as I move this, what I'm looking for is to try to match the curvature of the circle to best I can with the helmet that we've already got modeled, and then leave a little bit of a gap just between the edge of the circle and the hard edge that we have marked around this not so rounded out area behind the ventilation shaft. I don't know if that will help in you guys positioning it, but personally that's what I was looking for on my end when I was trying to position this. What I'm looking for now is I'm just trying to find the one that has the 32 vert count so I can go ahead and delete the one with the 24. Once we have the 32 vert circle selected, we want to go ahead and add an extrusion to it so we can add some depth to the geometry and allow the Boolean operation to take place. You don't need to do an excessively large extrusion such as I do here, we just need it to clip through the helmet a little bit. You'll notice here it's going to do too much of a Boolean, so we just want to select the faces that we want to have the operation run on and separate this from the rest of the helmet mesh. Once we have this separated, we want to go ahead and select our cylinder and then the faces we extracted, Control Shift and B, and do a difference brush operation with our Bool Tools add-on. The reason we're doing this is it allows us a little bit more flexibility with our positioning of the circle. So if it's not quite to my liking just as of yet, I could move it around a little bit more if I needed to. Apparently I was happy with the positioning straight away, so we can go ahead and apply that Boolean. Now this has absolutely destroyed our mesh. We have triangles and n-gons all over the place, but we're going to go ahead and try to find which vertices are the most pertinent, keep those, and dissolve everything else that's less important. I know a vertex is important if it has an edge currently connected to it, as I know that vertex was a part of the original mesh, or the other vertices that are forming n-gons with the faces are a part of the Boolean operation that we ran and are therefore less important. So you'll notice I go ahead here and I mark all these edges that currently exist as sharps, as I know these to be important, and I know that we need to keep these so that we can connect up this part of the mesh with the rest of the helmet. We can modify all the vertices on the inside where we have this Boolean cutout, though we don't want to do any drastic modifications to the outside, as that's going to be what merges back in with the rest of the helmet mesh. So the reason we have the Boolean cut in the middle here is because once we've finished connecting up all these vertices and we have a nice quad based mesh, what we're going to be able to do on the outer set of edges of this mesh is do an edge slide and have the edge slide conform to this circular cutout in the middle. So once we've fixed all this up and we have a nice quad based mesh, I'll show you how that works. You'll notice I just tried to do the edge slide I was talking about before, but it sort of cascades our geometry too much and we lose out on a lot of the mesh that we have. So what I'm going to go ahead and do is add in a support loop, and this will just allow us to better determine where our geometry is going to cut off with this edge slide. You'll notice that the top half of this mesh is still riddled with n-gons and a whole mess of topology. That's okay, because the main reason we've done this circular cutout is because we need the bottom of the mesh to actually have that nice circular fall off. So I'm not overly worried about the top of the mesh. So long as we get a nice curved base, it will all work out, and then we can start to retopologize the top section to be all quad based at the end. So we'll just drag this row of edges down until it actually terminates with the mesh, and then we can go ahead and either just completely delete these edges below it, or as I'll do in just a moment, slide them up and then remove our doubles. If you wanted to, because I only used about 3 or 4 of the vertices to actually conform to this circular cutter, if you wanted to, you could have done more along the outside, just extended that support loop. It's not a perfect circle by any means, or perfect curvature. I do go ahead later on in the series and start to tweak this a little bit more, but by all means you can adjust that edge slide to be as great or as little as you want. So now that I'm happy with the shape that I have, I want to go ahead and start to connect this mesh back into the rest of the helmet mesh. And the way we're going to achieve this is by aligning our bottom row of edges of the currently selected mesh with the base of that ventilation inset extrusion that we've done. So that's why I've just gone ahead and grabbed the normal of the separated mesh that we have, so that we can move the bottom row of edges down on that local or normal y-axis and line it up very well with the base of the ventilation shaft. Once we have these two meshes lined up, we just want to go back into object mode, select the two meshes, and conjoin them with Ctrl J. Just make sure you do that, as I try to do a merge operation while both of the objects are still separate and in edit mode, and as you'll see in just a second, it doesn't actually work. So make sure you join the two meshes back together, and then you'll be able to join the vertices back. Once we join in the two vertices down at the bottom of the ventilation shaft here, the rest of the vertices on the outside edge are going to be very easy to put back together, as we didn't do any modifications to those, and they will still line up with the rest of the helmet mesh. You'll notice on my end at least, we have one vertice that's a little bit out of place, and I choose to use the helmet geometry to merge towards that, as I figured that that was a part of the edge slide that we had done earlier with the Boolean operation. So I figured that that would be the better vertice to merge it to, as that should by rights have more of that circular design to it. Once we've merged those vertices together, all we need to do is just continue the extrusions along the bottom of the helmet here, just to match up with the new sets of geometry that we had. And we need to do this because this didn't actually exist before, now that we have that inward extrusion for the ventilation shafts. So we've certainly done the harder part of this tutorial, as we've already had to go ahead and deal with our booleans. Booleans can be a real headache sometimes. Sometimes they just won't work, sometimes they just cause a whole myriad of odd problems. But hopefully on your end, it's gone just as smoothly as mine. Yeah, we still need to do a little bit of retopology, but by this stage in the series, I'm assuming that you guys aren't going to be struggling too much with having to rearrange some of the vertices and edges. So I'll leave you guys to watch the rest of the retopology process in this section, and I will come back once we start to do some modeling with some Bezier curves to create the foundations for where we are going to apply that hexagonal ventilation tube. It's going to be a rather clever process using one Bezier curve, a circular curve, and about 3 array modifiers with a singular hexagonal object. It's rather cool, and I'm sure you guys will enjoy the process. Okay, so we're about to bring in the Bezier curve, that's why we've just adjusted the position of our 3D cursor. Once we have the Bezier curve in, we just want to orient it in the correct direction, scale it down a bit, and then make our first extrusion so we can see a set of lines to indicate where our curve is aligning to. Now, I have no specific method for moving these curves around and adjusting them. It's honestly just a lot of rotation on the global axes, some on the normal axes, and really just eyeballing all of the design to see something that conforms to the shape of the helmet that we currently have. I do eventually go ahead and add some geometry to this curve just to make it a little bit easier to see. You guys can go ahead and do that now under the curves panel. I believe you add a bevel to it and that will give the depth to the geometry. But for the most part, it's just a lot of pushing and pulling of these Bezier curves until you create a shape that you're happy with and that you feel suits the design of the helmet well. Once you have these two control points in a position that you're happy with, go ahead and select both of them, and we are going to subdivide the Bezier curve so that we have a third control point in the middle of the mesh. As you'll notice at the moment, our design is a little bit straight and it doesn't actually conform to the curves at the front of the helmet here. So this third control point will just allow us to add a bit more bend to the design of this Bezier curve. Just a handy little tip here that I actually only learnt about curves when recording this tutorial. If you use Alt-S, you can actually scale the size and depth of the bevel that you've added to the Bezier curve here. So I do that to taper in the base of the curve, and then I use it to expand the size of the curve at the top here. It was something that I just happened to randomly stumble upon while doing this, and it worked really well for designing the type of tube that we are doing on the helmet here. As far as where I'm trying to line this up, from the side orthographic view, I'm just trying to leave a nice bit of space between the top of the helmet here, or the top of the ventilation shaft, sorry, and the top line of the Bezier curve. So you'll notice I'm just making small adjustments just so that on my side orthographic view, it looks to line up nicely with just a little bit of offset from the roof of it and the actual tube itself. Now that I have the curve in a state that I am happy with, we can go ahead and do the really cool part of this tutorial and make this hexagonal array along this curve that we've just modeled out. So make sure that the origin point for the curve is at its center, and then let's make sure that the 3D cursor is also at the center of the Bezier curve geometry, as we need the hexagonal object that we're modeling right now to be at that center, as well as the circular curve that we bring in just a second to drive the pattern that we're going to make. We then want to bring in a circular curve. Once again, that's going to be at the center point of the Bezier curve that we've already modeled. Once we have that, we want to add an array modifier to our hexagonal object, and we want it to be a constant offset as opposed to a relative offset for this first array modifier at least. Just to save you guys a bit of time, we want the X positioning to be about 0.869, and we want the Y position to be at around 1.499. We also want to enable the clipping or the merging so that we don't have any discrepancy between the first object and all the other objects in the array afterwards. With that array modifier set up, we want to add a curve modifier and then set the target to be the circular curve. We can then go ahead and scale our hexagons down and add another array, make sure all the arrays are above the first array and the curve modifier that we've placed in, and now we can start to make this nice circular hexagonal pattern. Once again, we want to make sure we enable the merging option in our array so that we don't have any doubles or any inconsistencies with where the vertices on the hexagons are aligned with the array. Now, you'll notice that the hexagon circle that we have right now is way too large. So go ahead, select the hexagons and the curve, the circular curve that is, and scale them both down at the same time. If we scale one or the other, you'll notice we get some really strange effects going on. So make sure you scale them both at the same time, and then to adjust the actual positioning of just the hexagons, we can scale just the hexagon mesh, and that will adjust the positioning of it. Once we have the hexagons aligned properly again and we're happy with it, we can go ahead and we can apply another curve modifier to our hexagons, and this time we're going to target the Bezier curve that we modeled for the tube. Now you'll notice that this is oriented incorrectly, so select the hexagons and the circular curve and rotate these 90 degrees around the Z axis. Once we've done this, we can scale them back down so that it properly fits in with the shape of the curve that we did earlier. We can add a final array modifier to our hexagons here, and this is going to be responsible for the array of pushing this circular design all the way down the length of the Bezier curve. Now, a rather cool thing with what I've just taught you guys to do with this setup of the three meshes, or the two curves and a singular mesh, and the setup of the three arrays and two curve modifiers, this will work with just about anything as far as I'm concerned and what I've experimented with. So it's very versatile, a rather procedural sort of setup for using any designer mesh to create the same effect along any types of curves. And with that done, that will round out our tutorial for this episode. So well done, we have learnt a rather cool skill in the array and curves section of this tutorial, and we are getting a result that is starting to show a little bit more detail. So well done guys, and I will see you in the next tutorial.